before introducing self-attention, let me step back for a second and let me remember you what the RNN was doing. And the reason is that we will try to understand what an RNN does, so we will understand what the self-attention should do to replace the RNN. So the RNN was applying this equation on the elements, one element at a time. Let's look at this example here. So the RNN is trying to produce this new encoded vector H2, which is basically a new encoded version of the current input, which is X2, but also considering the context from the past. If you remember, the RNN was trying to capture the relationship between elements, and the way it does that is when applying the equation, is looking at the current element only, but also at the previous internal state that hopefully capture the context and the information from the previous element in the sequence. So that's how we can kind of combine them to come up with some more contextualized view of this information. And you see that the RNN was able to look only to the past, so only the information that were coming from the past and only to the current element. We'll see that this is not the case with self-attention. So self-attention wants to do the same, but he wants to do this using the idea of attention. So if you remember, attention was basically solving a problem. Given a particular state and given a sequence, find me the elements that are important in this sequence. And here the problem is shaped in this way. Given a sequence, which was the input sequence from before, if I take one element of this sequence, which is the element I want to create this new encoded version, use the attention to find the elements in the sequence that are important for the context of this element. So we will see this with the example. It's probably going to be more clear. So let's say that we have this sequence. This is exactly the same sequence that you saw before. And you see that I'm focusing on the first element here, so x0. And in fact, I put x0 here to make it more clear. So I want to compute this. In the RNN was the internal state. Here we don't use these words. Here we call that this hidden state, or this new encoded version for this element. And we want to use attention to do that. So what we want to do is to use attention to find all the elements in this sequence that are relevant to encode the important context for this element. So something like this. We use attention to somehow compare the current element x0 with all the other elements, including itself, and came up with these weights that are telling me which element in the sequence is important for the current element x0. And this is exactly what we were doing with attention. And in fact, at this point, where I have the weights, I will do exactly as before. I will do a weighted sum, and the output of this weighted sum is my hidden state H0. So the new encoded version of X0 that hopefully is also capturing the context from the other elements. And again, we use attention to decide which element was important to capture this context. At this point, we only have the first encoded vector H0. We need to repeat this again and again as usual. So we will do exactly the same here. So it's exactly the same computation. You see that now I'm focusing on X1. And in fact, here now I have X1. And then we will do the same for all the elements in this sequence. And at the end, I end up with it. So now I have a hidden state, so an encoded state that for every element that hopefully is capturing the relevant context also from the other elements. And you can see one thing, that self-attention has not this left-to-right nature. Given we do a weighted sum, it can extract this information from everywhere, from all the elements, according to the attention equation.